So I have this malware sample, and it's like 4,000 lines of Visual Basic script, the native built-in language that will run on Windows with a whole lot of fluff, but ultimately this is a stager for the REM-Coast rat, or the remote access Trojan. There is a lot of noise and nonsense, garbage stuff in here, but if we scroll down and eventually bring us to the absolute bottom, it's a little bit interesting. They do have a code signature here, and then more of the syntax, more of the code that we actually care about that acts as the detonator and really invokes REM-Coast. So in this video, we will do some static analysis and a little bit of dynamic analysis, and I think there are some interesting roads to go down. But hey, let's dive in. I am inside of my Remnux virtual machine, the reverse engineering malware Linux distribution. I'll hit Control-Alt-T to open up a terminal, and I'll move into this directory called UAC for user account control. Now, I have a file in here that is just the SHA-256 hash of the sample. It is a VBS script, and currently inside of the zip archive. Let me go ahead and extract that with 7-zip. I'll use X to extract. Password, as usual for malware samples, is just the word infected, all lowercase. Hold it, enter on that, and now we do have that file here. I'll open that up in my text editor, and we're back to where we began with all of this nonsense. Now, bear in mind, a lot of this is just junk. It's not actually anything that even runs or executes, just variables being set to random nonsense values and never actually being used in the actual code. Same thing with a lot of these REM comments. So what we could do is, honestly, just to try to find, I don't know, the wheat from the chaff here, find the needle in the haystack, let me go ahead and remove all of those comments. So lines that just start with REM, I'm using Control-H to find and replace within Sublime Text. I'll use the regular expression with an anchor tag at the very stop. Hey, just the start of the string with an arrow. Let me use the / to follow anything following a REM keyword. And I gotta be honest, I just want to replace them with nothing. So let me replace all, and that will do that for me, and they're all gone. Now, let me go do the very same thing with all the private const keywords, because those are just setting up variables that likely aren't going to be used. If later on we find, we're missing some variable declaration that actually is used, we could roll that back. But for now, because there's so much of that crap, I just want to get rid of it. Let's do the exact same trick. Hey, just cutting up the start of the line, private const anything, and then nuke that. Okay, so we have a lot now of empty space. Let me see if I can just grab the start of a line that is a new line following and then replace those. So now we get down to, I don't know, let's see, we started with about 4,000 lines, now we're about 500, and we could probably kill this signature because look, we're not super interested in that. Yeah, 500 lines of code, a little bit easier for us to parse than what we had previously. Let me go ahead and save a copy of the script. We'll say modified, I don't know, we can call that like 001 modified, that it doesn't matter. Now, as this is Visual Basic script, there are no secrets here. It's all just a scripting language source code that we can read with our human eyeballs. We're not digging through Ghidra or IDA or doing some disassembly, decompilation, whatever. We don't need to get into that hardcore stuff because look, this still works as a threat vector. So ultimately, we create a file system object with a random variable name. Probably worthwhile to change that to something that makes a little bit more sense to us. File system object, and then we have unquote given a special folder retrieved from that object and a text file that's included. What if I rename that to skibs file? I guess that's what that's called. And then we have some variable that is never used anywhere else, so we don't need to worry about that. We could kill that one. Same thing with our observations poster. Is that even going to be used? Let's Control F for that. No, not necessary. Ultimately, our on arrow resume next is just whatever boilerplate stuff that comes with Visual Basic script. File system object delete file with the file that we just got a reference to is kind of interesting to me. Maybe they're using that in case this is ran multiple times to clear their previous tracks and then just make sure we can still invoke it and not clobber things as needed. But that's peculiar. We may be working with this later on, so we'll keep that in mind. Then we have this assimilationist function call, apparently called a lot with 4 brugged passed in as an argument. I'm curious what that is. It is defined as a function down below, and very, very interesting. It's just these lines. Now, note, in Visual Basic Script, the way that you return a value from a function is by having literally the same name as the function. So this is just returning PowerShell, and then this variable, not used anywhere else, not important to us. All this does is return PowerShell. That's it. That's literally what this does. It's being passed into this other function, assimilation139. Let's go find out what that is, because it's called 254 times. A little bit interesting. Looks like it's cutting up some syntax. Let's see. Where is that? Let's get to the very first occurrence and then work backwards. So it is a subroutine where we pass in an argument, some argument. And we have a variable where we set it to our open text file with our skibs file. Interesting. What is the argument 8 here? I feel like I need to Google that. Same thing with true. Ultimately, we just write the data to it. So this says could just very well be file handle. That doesn't matter. And command ends up being something. Where is command coming from? What is that? Is that just going to be nothing? I mean, this variable doesn't do anything. Yeah, it's never used, and that's just probably a null value anyway. So that line doesn't really matter to me. But it is going to be writing and staging some contents to this file. So what we could do is do some quick research to go figure out what that syntax really is when it is being used with other arguments. We have object that's required, the file name that's required, IO mode could be any of these for reading, for writing, for appending, and then create, which will be true, in this case, Boolean value to create it or not. So the settings here for appending. Okay, so it's just repeatedly appending on with that value 8 to add to the file that it stages here. So our skibs file with we can rename this add to skibs file. We can go back to the top where we see this in action, and then this other variable doesn't matter. Add to skibs file CHRW34. What is that? Let me just check Python real quick. Oh, Python 3. What is the character representation of 34? Oh, okay, a string. So looks like it's going to be staging what would be arguments to PowerShell provided as a string with all of this. All right, we are still seeing a lot of variables that are created but not actually used, so those don't matter in my mind. I'm curious if there are any others, but no. Look, at this point, really, the point is to get all these PowerShell arguments out so that we could work with that. So what is the very end of this where it might just actually create the file or do anything with it? Once we've added our last quote, so presumably it's actually put everything that it wanted to for PowerShell syntax into the file, we go ahead and open the file, read from it with sk2, and then we run it. Okay, so it's just executing with wscript.shell all the PowerShell syntax that we just staged. And that's all that we need. So look, can I go ahead and then just sort of let this do what it needs to do? But actually, rather than running this, we could use a single quote for a comment or rem, as we saw previously. I just kind of want to see all that output. Let me try to, what is it? wscript.echo, I think, based on the value sk2 that's pulled out. So let's go put that in Windows and let this unravel itself without actually executing. We know, hey, we've diffused this here by not executing that PowerShell syntax. Let's just display it on the screen so we can pull that out and then analyze it. Okay, so I am inside of the Flare virtual machine to work things on the Windows side. And then let's go ahead and make a folder for us to work in, UAC, and I will go ahead and actually open up Visual Basic Script Editor, VBS Edit, which is one of my favorite ones to work with, and let's see if we can paste in all of the syntax. Paste in. Okay, looking good. Let me go ahead and save that into that UAC. We'll call this stager.visualbasicscript, and we should just echo this, so we're not a concern of actually detonating and running it. Let me open up the commander prompt here, and I'll move into our desktop in UAC, where we do have it in the current directory, and I can invoke it, just willingly trusting this, hey, with our stager.vbs. There we go. We can see all of the output given this PowerShell stuff. Let me see if I can just redirect that. Let's run that same command, but put it to subcommand.ps1. How about that? Can I open that? And it doesn't have to be Visual Basic Script. I just want to see the source code. Yeah, just consider it text file. I don't care. Okay, so we have that syntax. Looking good. Let's bring that into Remnux and kind of keep messing with it within Sublime Text. All right, let me save this as our subcommand.ps1. That's fine. We don't need that banner there, and we also don't need the strings at the end here because ultimately this blob is what is executed as PowerShell with some oddities in the mix, right? Not all of this probably even matters to us. So let's break this up with a couple semicolons and new lines. We have an oddball CMD command to set a variable, but not actually being set to anything, just doing math, and then a couple functions that we could clean up and work with. Now, again, I don't often find like a clean and pretty like PowerShell beautifier, so if those exist, please let me know. I'm totally cool with being schooled. Say the word, let me know in the comments, but for now, I will just cruise through trying to clean this up to make some sense of it. Okay, this is basically done, and we can get a little bit of a better idea for the structure here. Looks like we have variables defined with randomness included as a string, all passed to this Albertus function, and that's done over and over and over again. We have a variable kind of staged here, and frostfies might be something that we're looking for, where we do call this reflectorizing function that presumably does something with all of the output from Albertus. And actually, if we take a look at it, looking at the function definitions up here, reflectorizing is basically invoke expression. It's basically run this PowerShell code that we provided for you as whatever argument. Rebuffably is being used as a constant stager. I'm curious what Albertus on this might return, but that argument that's passed in will end up just being .sourced and ran and executed from PowerShell. Ridifodgers just is getting the length of a string -1. But this is interesting because this Albertus function is taking a character int of something that wasn't defined earlier. So that should be, oh wait, that is defined up here as this. What does that execute to? S? Is that because I know it's being used for the word substring. What is that character referring to of 115? S. Incredible. So this thing is the letter S, and that's not too hard. Stick pillar means that this is going to be the word substring as a function that it might call. Mistletoes being the number 8. And then this being the length of the provided string -1. That's just going to end up starting at index 7, while it's less than the length of the string -1, add 8 to it as an iterator, then take our substring that we know is a function that we'll call invoked with the current index up to 1 character. So it's getting just every 8th character and adding it to a list. So when we run Albertus on all this junk, none of the other stuff really even matters other than, hey, actually getting the 8th characters. Every single 8th character. So if we look at refubly, which we know is used in our reflectorizing function, this is so fun to say, 0, 1, 2, 3, 4, 5, 6, 7. So I should be our first value there, and then move up by 8. That should be E for literal genuine IE, and another 8 that should bring us to X. Yep, so IEX is genuinely what refubly is being built out to invoke expression, get some madness into PowerShell. Well, we could modify this reflectorizing tidbit and then literally just echo all of these things out, or just use Albertus to echo that value. That's probably fine to do. And then let's not do anything for reflectorizing other than maybe another echo. So again, we're just letting the malware sample unravel itself. We'll use write host here. We'll also do a write host here. And now we could just run this as PowerShell. Like, I'm okay with that. And let's see what we do. We're back in Flare. We don't need to be using that Visual Basic script stager anymore, but we could use something like ISE, the Windows PowerShell thing. We'll paste all it all in. We'll save as PowerShell stage.ps1, and can I run this? Oh no, I broke a lot of stuff. What's going on? It's because I probably broke some of the syntax here. How about now? Okay, yeah, now we're going. Look at these strings. It gets stuck in a loop for a little bit, but I want to kind of just take a look at what those are. All right, so we started with transferring as the output, and then a Google Drive file, which is peculiar. I kind of want to go see what's in that. Let me go look. Is this thing still up? Download it. Nope, Fari is infected with the virus. This file is infected. Only the owner is allowed to download infected files. Glad you caught that one, Google. IEX, invoke expression. Global preaches should be a bit bits transfer where we download my NAS. Where is that being set to? Oh, my NAS is actually staged as that variable, which would be our HTTP Google download, right? Yeah. Well, at this point, look, we've fallen down the rabbit hole pretty well. Like, hey, we did some of that static analysis, maybe we were mixing in a little bit of our own dynamic analysis, but it is worthwhile to, hey, slap this thing in one of those cloud sandboxes so that it could rip through and maybe find some other really interesting indicators of compromise, behavior techniques, or tradecraft that we didn't already pick up on. Now, you might already know, I am a huge fan of any.run. It's an awesome, hey, cloud-based sandbox that can do that dynamic analysis in whatever virtual machine that you put together here, and it shows you just about everything that it does. You can see the process chain over on the right-hand side, and just as we saw, wscript.exe, or cscript as we invoked it from the command line, just that parser and that engine to read through and execute that Visual Basic script code. It tells us everything that's a little bit sketchy about this, and then shows us the child process underneath it. We have PowerShell that invokes with the exact same command line that we were able to extract and pull out, and that's peculiar, clues us in as to other things that might follow. Of course, that cmd.exe following, and then this wab.exe that presumably was probably what it downloaded from Google Drive, had it been able to actually access that at the time. And hey, that saved, stored itself as an executable, and then it is the Remcos rat, the remote access Trojan that could later be used to keep controlling the victim computer that's infected with malware. So this gets into some other interesting stuff following that, because look, yeah, it adds itself to the startup registry, like, hey, have an auto run, have an implant and a little bit of persistence, does the very same, but something else really interesting kind of occurs that I thought would be worth digging into. There's this CMSTPLUA thing that happens, and it's apparently DLL host is actually getting executed, but it's working with a COM object, some of those component object models, and it invokes DLLhost.exe, native, natural, embedded, included, built into Windows, with the process ID of this unique GUID, or that unique identifier, right? But apparently, this bypasses user account control. Like if I were to open up, hey, any program that I wanted to right-click run as administrator, it will prompt me with the user account control. Are you sure you want to allow this to run as those high integrity rights? And that will tell me, look, you are invoking this as the administrator here. In some cases, that asks you for an administrator password, but even if it doesn't and it's just a yes or no dialog box, that pop-up kind of lets the cat out of the bag that, hey, something is happening on your computer. Malware is being invoked. So being able to bypass that is an attractive thing for a lot of threat actors and malware developers. And I wanted to learn a little bit more about this, like this CMSTPLUA, how that even happened, and what that GUID actually is. So apparently, I feel like an idiot because I had no idea that technique, CMSTP whatever, is a well-known privilege escalation vector and an opportunity to bypass user account control. Looks like it's been done for a whole lot of ransomware cases, Lockbit. There are tons of research and write-ups and articles about this thing, and goodness, I probably should have known that. Even if you, like, go ahead and look up LOLBAS, the living off the land binaries and everything, if we wanted to, we could look for that CMSTP.exe, and they dig into it. Look, the way that this works is that you can execute whatever code that you want in a little abstract, sort of indirect way, where you're using the CMSTP executable that will silently install with that /s a specially formatted local.inf file without creating a desktop icon, and maybe that includes a little bit of magic that'll execute a scriptlet file or some scrobj.dll, and that could do what you want. Kind of interesting because, again, this is a native Windows binary, so you've got your application whitelisting or allow listing bypass, hey, because, I don't know, it's trusted Microsoft executable, but looks like that could potentially pull things from the internet just as well. We actually wanted to take a look at that link. We can open it up. This is just what they link and reference in that lolbins resource, but you can see a couple of sections here for this INF file. Unregister OCX section digs into how it might call or execute scrobj, and then use this link to get an SCT file. And if we wanted to, again, we could just go track that down. It's online, it's on GitHub. We can go look. Nothing special, nothing fancy here. All it is, hey, some more execution to just stage calc.exe in this case. Hey, innocent payload, just a test. We're firing open the calculator, but that could be used to sneak and hide and maybe masquerade a little bit more of a payload. Now, I got a little bit curious because, look, I want to know how else can this kind of be done? Are there other samples that use that CMSTP UAC or user account control trick? A little bit of a bypass there. And any.run, again, phenomenal to be able to dig into these different samples, see everything that they do. Look, if we even dug into the more info section, you could see just about everything that it's pulling apart here, and that's pretty cool. But ultimately, they've just added this new piece of functionality that is so cool. It's called Threat Intelligence, and you saw me just click on that little TI over on the left-hand navigation. Look at how cool this is. It's Threat Intelligence any.run style, where you could dig into, hey, a whole feed. This is what they call the TI or Threat Intelligence feed of new samples, new submissions, new malware that's digging into any of the MITRE attack framework techniques. And you'll note they're all sort of suggested here at the bottom. You can see the sum of how many hits that they're pulling in and the technique itself, and then a little bit of the details as to what is actually flagging that and triggering on it, and then all of the example tasks that might be able to go actually see them in action. Look, I could just fire up the sandbox, click into whatever weirdness was going on in any of those hits. I don't know how well you can see here. Look, we've got strrat, we've got ransomware, a little bit of WannaCry, net support, a couple goo loaders in here, async rat, auto IT payloads, macros, of course. It's just, it's so cool to be able to see this literally at scale across the whole world for whoever is submitting and digging into what different samples here. And I do really like that it is organized by MITRE attack framework. So if there's something that you're a little bit more interested in, like any of the techniques, you could go see, look, what's the most recent stuff that's showcasing it. I realize my face is kind of in the way here, but look, if you wanted to toggle this between 60 days, 30 days, 14 days, 7 days, you can, and you could even export all the results here. That'll stage a download to pull that all down. And if you bring this into like a grid mode, it even shows you like the regular, usual MITRE attack framework, but you could drill down into scrolling for the stuff that you're interested in, and that's kind of neat. Like, look, I want to see anything that digs into domain accounts or some of the lateral movement segments there, shows you some things that are worthwhile processes that have been seen doing it, and then the tasks that you could then click into and then go explore that in action, see exactly what that attack chain is. And that is pretty slick. For my purposes though, as I know I'm just now interested in that UAC or user account control, that is one of the MITRE attack techniques, literally bypassing user account control. So if we wanted to, since we could search for that, and again, we're just searching for technique names in this case. If I want to look for anything regarding a domain or some sort of threat, some tradecraft and behavior, we could do that. But look, again, UAC, and I could just drill down into any of the other events, any of the other actual invocations, and what they do to see them in action. Configure as an example, we could drill down into any of the tasks. We have a link there to just open that back up in the interactive sandbox. And this one's pretty boring, right? Hey, they're just using the registry tweak to enable Lua, and that's it. But if we wanted to explore some of the others, we could see maybe what else is doing oddball things. DISM, can that be used to bypass UAC? It's not like in Lolbins or Lolbas. I didn't find it there, but I'm curious if you know in the comments, please tell me. And this is it. Cool. Look, UAC bypass using that CMSTP, the connection manager service profile that we were maybe getting smart on and reading up. This one's peculiar. This sample here, if we want to go open it, check it out. There is a lot of stuff happening in this invocation. Like you could drill down into any of the processes, the services, whatever you wanted to see and like actually happening in that sandbox environment. But look at all this stuff. They use CMD and then run tests.bat. So I'm going to assume it's like actually trying to test some things, decoding, hey, all the things DLL, bits admin, pulling stuff down. But here's what's interesting. Raw GitHub user content, EDR testing scripts. So if we wanted to go take a look at that, we could, but it looks like it's just testing a bunch of technical stuff, like, oh, some actual payloads or at least some benign malware samples are enough to say, look, this behavior, we want to make sure that our security tooling even sees that. So it's kind of neat, of course, to see that within any run. But look, here is certutil downloading a couple different things, and here is cmstp.exe trying to go use that exact payload, which probably is very similar, if not exactly, to the one that we saw over on Lolbins. Yeah, okay. Like if we wanted to go see that, look, it's literally the same sort of INF setup, and they use a very, very similar SCT in this case, which is just as the other one was, hey, pop and calc, simple test, simple benign thing to be able to evaluate whether or not it is detected. But that's a little bit interesting too, because if we wanted to go explore what that repository actually is and what it does, it presumably is, just a bunch of stuff to test your security solution, endpoint detection response. And this is old. You can see commits from 5, 6, maybe 3 years ago. Again, still something that's a little bit neat. Oh, wow. This is actually pretty comprehensive. There is a bit more that we could dig into if we really wanted to in that threat intelligence feed here. And there's a lot. Look, we saw all those different tasks and their tags. And if we really wanted to, hey, we could drill down to different submissions based off of different countries, geolocations, and they actually have some malware threat statistics. And again, I'm just on the filter of UAC right now, but pulling that down, it's kind of cool to get a little bit of a graph on like, look, what are the threats that are out there? Whether it's, staging ngrok, some tunnels out across the open internet, or configure domains being set up. I don't know, anything that we might be able to see for different samples themselves. Suricata rules, if you are looking at some of that network data. Not usually my world, but I do love that that is all here. And you can drill down into it, of course. The popular techniques tidbit that I think is the coolest thing. Just as we did with UAC, but actually taking that further because we can find other samples that are using the same sort of technique or something similar or references or breadcrumbs and puzzle pieces relating to that behavior. Like, look, this was potentially using that CMSTP user account control privilege escalation bypass here to do something shady. Literally Agent Tesla, where they actually have a malicious INF file being staged and set up, and we could drill down into this to see plenty of others. Another Agent Tesla stealer, a Rhinos Discord account toolkit. Oh my goodness, I gotta go see that one. Puke.exe. What is in that Discord one? Let me go take a look at that. Rhino Discord, setting stuff up. A lot of MS Edge. Okay, they must have probably like used the sandbox to download it on their own, and probably using this as it does, so we can see the invocation here, based off of that INF file. And if we go into more info, we could check out the modified files, and my face is in the way. Here, if we take a look at the modified files section, and we go up to see anything that runs it earlier, here, that's probably creating this INF file that we can view the contents of and then rerunning itself afterwards. You can see that in the process chain, but this is the exact same structure and setup that we saw just a moment ago. Instead, the commands that end up getting run are the executable itself, and then MSHTA to call and kill CMSTP.exe, because it doesn't matter if that's running anymore. We've already just invoked the actual potential malware, Discord account toolkit, whatever. But that is now high integrity because it's ran as the administrator, didn't have the prompt for it. So that's kind of cutesy. But again, look at all the results here. Look at all the hits. Here's another info stealer. First.exe looks like an opener for Rhadamanthus. I can never get that malware strain name correct. Azerolt's in the mix just as well. And you can see the different payloads. Obviously, it's just going to be a randomly named .inf file, but there's more in here, and that's kind of sweet. Xworm. Oh, I want to see Xworm. This doesn't look super interesting, kind of cut and dry. Hey, just we have a client executable that is Xworm detected. Hey, connecting to command and control servers and scheduling some persistence. The protector starter. Look at this though, the vimxworm.inf. If we want to go take a look at that, that's probably going to end up being written. Again, if I look at the modified files, probably for our client.exe, that'll stage, that INF file, which isn't anything spectacular. The exact same structure and setup for just running itself and then taking away the stager. CMSTP doesn't have to run anymore. I do think that is pretty slick, just to be able to, hey, dig into that and show you the variation, if any, for different payloads, for different malware samples, for things that might do this, use it, take advantage of that behavior. That capability. And that's literally why threat intelligence is what it is. If we want to go try and look up, and this is a cool new thing just as well. With all of the awesome new and incredible stuff with this threat intelligence new feature set with any.run, they also added not just the TI or threat intelligence feed, but there is the TI threat intelligence lookup, where you can, a little bit more with a sharper knife here, search for whatever you want. And they have a couple options, suggestions like, look, if you want to query based off of a threat name, can I search for just like emotet? Does that work? Let me see if I can search for that. Yeah. Super duper cool. Okay, so it gives you, again, a lot of the tasks that are pulled in, maybe some other info that we would like to pull. And yeah, okay, I did recently search for that just as well. But if we wanted to get our, hey, maybe specific to the United States, we totally could. Now, this is stuff that you had seen previously, right? Look, you also had all the capability from the other buttons. But if we wanted to combine a lot of this stuff, we totally could. Like if we wanted to do and, I believe is the operator here. Yeah. Or whatever. And there's more stuff we could put in the mix, or you could move into whatever different tabs to see stuff that is specific to what you're looking for there. The events are interesting because they could get literally any piece, any sliver of the attack chain. Like, look, these are just the moments that Microsoft Edge ran. But if we had a little bit more of a fine-tooth comb there, a little bit more of a scalpel, we could probably look for any component of an attack chain, something that you might write a detector for with detection engineering, and then be able to search that across just about anything that any run gets submitted to it and sees in its corpus. Actually, can we look for that? Can we look for like the command line, including cmstp.exe? Will that work? Okay, that's just it being ran on its own. Oh, killing it is one technique, but it's not the real thing. That /au is a little bit interesting. /au is used a lot for the INF. Can I add an and where it actually denotes an INF file at the end of it? Sorta, kinda. I'm curious about that first result. Maybe it's because it's still all in that attack chain, but look at all these. I wonder if we could just pull down all of those .inf files and see if there's any other odd ones that aren't just run the payload and then close CMSTP. That would be kind of interesting. But again, drilling down into any of these, we can pull up the actual sandbox notion here, and this is Bonds. What is going on? It's Bonsai Buddy. Oh my goodness. That is hilarious. Wow, that is insane. At the very least, Bonsai Buddy is using that CMSTP UAC bypass. All right, so I've been rambling for a little bit here, but if anything, I hope that was kind of cool to dig through a little bit of that malware sample, fall down the rabbit hole of Visual Basic script to PowerShell, and then doing our static analysis and some dynamic analysis, but then leveraging it with some threat intelligence. Because the coolest thing is if you see, ooh, that's an interesting part of an attack chain, or ooh, that's a little bit of a cool technique, or some behavior that I want to see more of and see what else might do it, or just tracking different families, different strains of a threat actor, cybercrime, or malware. That is why threat intelligence is so significant across today's cybersecurity landscape. And I'll be totally honest, I think AnyRun's new threat intelligence, TI lookup, TI feed, like they look really good, and it's kind of fun just to explore, see what's out there. We got a little bit of a case study showcasing that user account control, or one tidbit of the MITRE ATT&CK framework that we could hone in on, see what else is out there, and you could do this in much more depth and detail. And if you really want to, there is a link in the video description for you to dive into using AnyRun's new threat intelligence lookup and threat intelligence feed, all that sweet intelligence for tracking malware. If there are any tricks, any techniques, any tradecraft, or things that you just want to track with a little bit of that threat intelligence, I do honestly invite you to, hey, go try AnyRun's new threat intelligence feature set. I think their TI lookup and their TI feed is pretty stinking cool, and you can have whatever request that you'd like, again, with a link in the video description. Thank you so much to any.run for sponsoring this video, and if you did enjoy everything that we got to dig into in here, please do all those YouTube algorithm things. Like, comment, subscribe, and hey, I hope to see you in the next video.